Powers of binomials. Okay, this is section 4.2, even though the number ain't up there. All right, 4.2, powers of binomials. Two warm-ups to get you going here. X plus y quantity squared, x plus y quantity cubed. All right, now I will tell you this. I won't tell you what the answer is. I will tell you what the first answer is not. Your first answer is not x squared plus y squared. Okay? It is not x squared plus y squared. So this first one here, x plus y quantity squared, anybody get it? X squared plus y squared plus 2xy. Good. I'm going to write it out a little different though. When you square something, what do you do to it? Times it by itself. So here we're squaring x plus y. Right? So we're going to take x plus y and times it by x plus y, which means we're going to what? We're going to FOIL it, right? So x times x, x squared. X times y, xy. X times y, xy, putting them in alphabetical order. Y times y, y squared. You got like terms in the middle there. So it's x squared plus 2xy plus y squared. Makes sense? So by the same logic, if you're going to square something, you're going to multiply it by itself 2 times. When you cube something, you're going to multiply it by itself 3 times. So this one, the second one here, x plus y times x plus y times x plus y. Now this one can get a little nastier. I'm going to pick up the first 2 FOILs, right? These 2 are just the same ones that we just did. So that'll be x squared plus 2xy plus y squared times another x plus y, turning it into a problem that we did last lesson, right? Okay, then you do your trinomial times a binomial. So x squared times x, give you x cubed, plus x squared y. Now go to this term times those 2, plus 2, x squared y, plus 2, xy squared. It's these 2. And I'm going to have to go down a rung for the y's, but plus, whoops, don't want to change colors just yet, plus xy squared plus y cubed. Okay, so all 6 of those, and you got like terms amongst them. So your final answer is x cubed plus 3 x squared y plus 3 xy squared plus y cubed. That's what we're doing today. We're going to take these binomials and we're going to take them to all different kinds of powers. To the second, to the third, to the fourth, to the fifth, to the sixth, seventh, eighth, maybe ninth, maybe 10th, who knows? Okay? Which means there's going to be a whole lot of foiling going on, right? Actually, no. We're not going to foil the rest of the class. Okay? So when you look at this one on the notebook, I want you guys to pay attention to 2 things, because I'm going to get rid of this, so you have to look at yours. I want you to pay attention to these 2 exponents, 2 and 3. I want you to pay attention to, secondly, the number of terms here. There's 3 terms here. There's 4 terms here. I want you to pay attention to the coefficients. 1, 2, and 1. And then 1, 3, 3, and 1. Okay? Keep in mind those 3 things for our next slide. Alrighty. But do those 2, as far as the execution, come up with answer, make sense? Yes? Great. Moving on. Okay then. So, a little background. there was this mathematician. His name was, if you can guess it, Pascal. French dude, I believe. No, Chinese. I think a Chinese dude is what the book says. Anyway, he came up with this little thing, this little theory about your coefficients to when you do all these powers of binomials. Okay? And once you put it together, it's pretty slick. Yes, I said slick. All right? So you start it off with taking a binomial right here to the 0 power. And as you guys all know, anything to the 0 power is 1. Okay? Anything to the 0 power, 1. What's anything to the first power? No. What's 3 to the first? 3. 4 to the first is 4. 5 to the first is 5. Anything to the first power is itself. Okay, so now here's how this works. Your coefficients here, this is what this is building. We're building coefficient numbers. Your coefficients on x plus y are 1 each, right? So 1 here and a 1 here. You can see I'm going to build this like a triangle. Okay. Now we have the problem we just did. Right? X plus y quantity squared. Those coefficients were what? The numbers in front. First one was 1, right? Second one was 2. Third one was 1. 1, 2, 1, right? From last slide, x squared plus 2xy plus y squared. Remember that? Okay, what was 3? 1. Then 3 and 1. And he started catching on to this relationship. So he did a 4th power, he did a 5th power, he did a 6th power to figure it out. And here's how the coefficients of these numbers go. Ready? Okay, so 4, I'm going to tell you, is 1, 4, 6, 4, 1. 5 is 1, 5, 10, 10. 5, 1. See how he's building up a triangle? See that? And I'll go one more for you. I'll go to 6. It's 1, 6, 15, 20, 15, 6, 1. The 7th, you don't have to write this one, but it would be, well, let me think about this. It would be 1, 7, 21, 35, 35, 21, 7, and 1. Whew! I couldn't tell you what 8 is off the top of my head because I need to write down 7 first. Okay, but you build this triangle, this Pascal's triangle. All right, now, quick question. How am I getting these numbers? Just pulling them out of my butt. Look at what's up there. Look what's up there. The ones I'm just mowing down the left side and the right side. Makes sense? See that? Okay, that one's pretty obvious, right? What about the middle ones? Adding what, Cozy? Adding the 2 above it. There you go. What's 1 plus 1? 2. What's 1 plus 2? 3. What's 1 plus 3? What's 3 plus 3? 3 plus 1. See that now? 1 plus 4, 4 plus 6, 6 plus 4. And then it's on like that down the way. Okay. So that's how you build that triangle. You add from above. Okay, so your 7th power, that's how I got it. You take 1 plus 6. You start with a 1. You take 1 plus 6, that's 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6, and then 6 plus 1, and then put another 1 at the end. Okay? If you don't have your calculator, that's what you get to do. That does have the calculator. Hit program. Oops. Pascal. Enter. Row number, for row number, you want exponent number. Okay, whoever wrote this was a little iffy about that. Alright, so 5 is the second to last row. This one, let's do 5 just to prove them right. Okay, so hit 5, hit enter, boom. 1, 5, 10, 10, 5, 1. Pretty slick, huh? Yeah. Okay, hit enter again. Let's try 7. Let's see if I had it right this morning. Oh, look at me go. I'm on fire. 1, 7, 21, 35, 35, 21, 7, and 1. Okay, see that? Everybody good? So you don't have to write this triangle out if you have a program. If you don't, you do. Have fun. Because I will go to 10, no doubt. I will go to 12. I can't. You have this. Or you're supposed to. Okay? Make sense? Now, that's just the numbers. Okay, so that's not everything. Alright, we're going to get to everything here. Okay? Now, kind of watch me on this before you go do it. Alright, just because the slide looks really weird and everything else. Okay? So watch me at first, and then I'll give you time to write it down at the end. So what we're going to do, let me take a drink. Oh, boy, that was delicious. What we're going to do is we're going to take x plus 6, and we're going to expand it to the 6th power. Which means we're going to do x plus 6 times x plus 6 times x plus y 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 times x plus y. So you have two choices. You could write out x plus y 6 times and foil, and then 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 foil. Or you could do it like this. Okay? First thing you do, hit Pascal's triangle app, hit 6, and get your coefficients. Okay? It should be, if I'm not mistaken, what, 1, 6? No.
1, 6, 15, 20, 15.
1, 6, 15. 20, 15, 6, and 1. Okay. Those are your coefficients. Those go in the front. 1, 6, 15, 20, 15, 6, and 1. Okay, these are the coefficients. Now I'm going to write the two that we did at the very beginning of the lesson. Remember those? I'm going to write them up here. Okay, so we had what, x squared plus 2xy plus y squared was our first one, right? Then we had x cubed plus 3x squared y plus 3 xy squared plus y cubed is the second one. Those are the two that we did at the beginning of the lesson, right? Okay. Now, obviously, we still have x and y's in this binomial, so we're going to have x and y's throughout our answer. Okay, so that's why they're all there. Okay, does that make sense? Now, the only thing we got to figure out is the what? Starts with E. The exponents. We got a whole lot of exponents to figure out. Okay? To do that, I want you guys to look at the first two that we did. Okay? When you got x squared, what did you do from the first one? That first answer, when we got x squared, you multiplied what and what? Multiplied x and x, right? X times x gave you x squared. And that was it, because that's all you had to do, right? On that third one, multiplied x and x, you got x squared, and then later on you multiplied it by another what? First thing you multiply that x squared by, you got an x to the third because you multiplied by another x. So we got x cubed. So what's this first exponent on x going to be? 6. Because it's going to match this one. Think about if you wrote them out 6 times and you did all that foiling, that first x, and multiply by that first x every single time 6 times. So x times x times x times x times x times x. X to the 6th. Okay. Now look at these two and find a pattern on your exponents. There's a pattern there.
What you wrote, that's not relevant.
That's not relevant besides just helping you out. No, that's correct. But there's a pattern there that will help you. Hmm?
The single x and y had the same.
Single x and single y at the ends have the same exponent. Everybody see that? This one, this first x has an x squared, this y has a y squared, this one has an x cubed, this y has a y cubed. Alright, that's correct. Jumping my gun, but that's okay. So this y down here will be y to the 6th. One more though. Really need it. Because we have a whole lot of middle to figure out, right? Because all these x's and y's need exponents. Playing fill in the blanks. So we got 1, 2, 3, 4, 5, 6, 7. We got 10 numbers to figure out yet. Look up.
Is it the x, 3x squared y and plus the 3x y?
Yeah, what's happening with your exponents?
One of them has like the x-axis squared, but the other one is not. It's y.
Okay, but now, okay, so that's good for that one, but what about as we move into bigger numbers? Because you have more terms to fill in than just 2 here, right? So they can't all be squares and singles and singles and squares. What happened from one term to the next? Here to here, with regards to your exponent. From x, it went down. Hmm? My x added a 1? Went from 3 to 4? Subtract 1, right? Went from 3 to 2. Then from here I went from 2 to 1. From here I went to 1 to 0. So this x might be what? X to the 5th. This next x might be x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then x to the... No, this is a y. This one would have an x to the what? 0, which is 1. And 1 times this is 1, so we don't write it. You go down by 1. In this term, all the way down. Okay? Now, what about your y's? If they start here at 6, then what do? Look down here. From right to left now with your y values, they go from 3 to 2 to 1 to none, so they're going to go 6 to 5 to 4 to 3 to 2 to 1, and again none. Okay? So that's how you write that out, okay? Yes, these answers, guys, are going to be very, very long. Yes, they are. Okay? I know that. Half the battle is being organized with it. That's half the battle, okay? So my suggestion with these is this. I would get your coefficients, I would write them off to the side first so you know. Okay? These exponents from here to here, always the same. This first variable is always going to be the same first variable, and it's always going to be that same exponent power. Okay? And then it fills in from there. Your coefficients in front. Your variables start going down by 1. So 5 on the x, 4 on the x, 3 on the x, 2 on the x, 1 on the x. Your y's go up by 1. 0 y's, 1 y, 2 y's, 3 y's, 4 y's, 5 y's, 6 y's. Okay? Okay, so, hold on a sec. Let me see something. Okay, so, x minus y to the 6th. So, what changed? The sign. Good. So, everything else stayed the same. X and y's, exponent of 6. Okay? So, that means your coefficients that are in front do what? From the last one to this one, your coefficients that are in front, no, let's not go there. But the coefficients themselves, let's put it like this. What number are you going to put on Pascal's program? 6. They're going to stay the same, right? Still going to be 1, 6, 15, 20, 15, 6, 1. Your exponents. Your x's start at 6, your y's start at 6, so the exponents throughout are going to stay the same. Because we're still going to go x to the 6th, y to the 5th, or x to the 6th, x to the 5th, x to the 4th, on, whoops, wrong button, on down the line. So, here's how you do these. You hit your Pascal's program, you get your coefficients, 1, 6, 15, 20, 15, 6, 1. You always start positive. Okay? So you start with your first coefficient, which is 1. Here, green. Boom. So 1x to the 6th. And here's what I would do. When you write them out like that, I would cross it out when you're done with it. Okay? Here's what I'm going to kind of help you out. Your next sign is going to be a minus. Since this sign's a minus, that'll make this sign a minus, okay? Roll with that. Your next coefficient's what? 6. Then you have x, which this time's going to be to the 5th, and you add in, you start your y's. Okay? We're done with this guy. Your next sign is a plus. You'll catch on why. Your coefficient is 15. X to the 4th, y to the 2nd. See how you do that? Your x's, your first variables go down 1. Your second variable is going up 1 now. See that? 1 to 2. Your next sign is a minus. We're done with 15 up here. Your coefficient is 20. X will be to the 3rd. Y will be to the 3rd. We're done with this one. Your next sign is a positive, a plus. 15. Downhill slide now. X will be squared. Y will be to the 4th. Next sign is a minus. Coefficient is 6. X will be to the x 1. Y to the 5th. your next sign will be a plus. Your coefficient is 1. X will be to the the 0, so we don't need it. Y will be to the holy answer. Now, this next slide has a few helpful hints as far as, and these will be helpful today. We're also going to definitely need them more so tomorrow, okay? Because we're taking 2 days on this, today and tomorrow. But they are helpful today. A lot of this you already kind of picked up on throughout just kind of working these problems the past 2, and also just kind of paying attention to certain things. But just stick with them. That's our sock box. There you go. Few things that always happen, okay? Number 1, if your expansion is the a plus b to the n power, all right, so whatever that exponent is, there is always that exponent plus 1 more term. Okay, so if you look back, the first one we did, when we squared it, we had 3 terms. When we cubed it, we had 4 terms. The last 2 we did, when we took them to the 6, each one of those had 7 terms. That's a key one to remember. That way you know if you got them all or not. Okay? Make sense? That's a good one to keep in mind at all times. The rest kind of just fall in line, if you know what you're doing. You know, like the second one, n is the exponent of a in the first term and b in the last term. That's just like what Ivo said. The first term is going to be x to that exponent. The last term is going to be y to that exponent. X to the 6th, y to the 6th, like the 2 we did. Okay. Number 3, kind of big boy words, but be careful with them. In successive terms, the exponent of a decreases by 1, exponent of b increases by 1. So here they're using a plus b, pretend they're x plus y. We already talked about that. X goes down by 1 from term to term, y goes up by 1 from term to term. Okay, we talked about that. This last one is going to be more useful tomorrow than it is today. But if you picked up on it, great. The sum of the exponents in each individual term has to equal the exponent that you start with. Okay? So if you look back at the last problem, we had x to the 6, 6 plus 0, 6. 5 and 1, 6. 4 and 2, 6. 3 and 3, 6. The sum of the exponents is always whatever exponent you have right there. And another one that's kind of like, it's good to know, but it kind of falls in line with when you have Pascal's triangle, your coefficients are symmetric, right? 1, 4, 6, 4, 1. They kind of go up and then back down the same way. 1, 6, 15, 20, 15, 6, 1. Okay? They're big ones to make sure you remember, I would say, is this one right here. And then for tomorrow is this one right here. That was a terrible check mark. There. Well, still not a great check mark. Let's try that one more time. Ooh, there we go. Okay. The rest, if you paid attention today, you should be able to pick up on fairly easily. All right. All right. So for this one, you're buying your your coefficients. That's the word I'm looking for. Go 1, 9.
Wait, we got that. I'm on that.
36. 84. 126. 126. 84. 36. 9 and 1. All right. Roll them sleeves up. X to the 9th. Now, the nice part here, I made the middle sign a positive, so they're all plus. Okay, so that's a plus. He's got jokes. Plus, your coefficient is 9. X to the 8th. Y. Don't forget that first y. Okay, you forget this first y, there's no promises you'll remember on the next term, then the term after that, and then it could cause you chaos. Okay, Grace?
Okay, so when it's
Oh, plus there's no alternate.
Correct. It's all plus.
Okay.
Okay? All right. Plus 36. X is to the 7th. Y is squared. Plus 84. X to the Y to the 3rd. Plus 126. X to the Y to the 4th. Downhill slide now. Plus X to the Y to the 5th. Good. Plus 84. X to the Y to the 6th. Plus 36. X to the 2nd. Y to the 7th. Out of room. Enter return. Plus 9. X to the 1st. Y to the 8th. Plus 1. Y to the 9th.